Hello and welcome back to the Kaloran Show. Today we are on lesson 81. We will be using proportions to solve percent problems. Just remember, the beginning of good notes starts with a good title. Get lesson 81 and using proportions to solve percent problems, because that is exactly what we will be doing today. Don't forget it. To start out, we have this example. 40% of the students at Lincoln Middle School do not buy their lunch in the school cafeteria. If 480 students buy their lunch in the cafeteria, how many of the students do not buy their lunch in the cafeteria? I know you're really excited because you see a ratio box. Yes, we are going to be using ratio boxes today. Why do we use ratio boxes? Well, because some of you are still in the process of organizing your information. So this ratio box sets us up perfectly for organized information. First thing we need to look at and take out is the 40%. Okay, why? Because it's a number. We don't always take numbers out, but 40% is a very important one. 40% of the students at Lincoln Middle School do not buy their lunch. Okay, so in our ratio box, we are going to put do not buy lunch. Give us a label so that we know what we're dealing with. Okay, our do not buy lunch is going to be represented by a percent. And what percent are we going to use? 40%. If 400, next information that we need, 480 students buy their lunch. So there you can see your new title, buy lunch. Here, do not buy lunch. Now we have buy lunch. And now we have not a percent, but an actual. So what are we going to fill in here for buy lunch? 480. Okay, if you want to, so you don't forget what to label, you could put your students in this ratio box. It might make it help you remember what your label is in the cafeteria. How many of the students do not buy their lunch in the cafeteria? So that helps you be able to figure out what you are looking for. And what we are looking for is how many students do not buy their lunch in the cafeteria. So we are looking for, we could just put an X in the box we are looking for. So that's the one we are trying to find. So now we still have a lot of blanks, right? You're thinking, how are we going to solve this problem? Well, the only other information that we're missing down here is our total. So you need to figure out what a total is. Well, I don't know any of my totals, you're thinking, Miss Clark. But you do know your totals, because if we have all the students there, there is 100% of your students present. So this will help us fill in our number of student, or our percent of students that bought lunch, because 100 minus 40 is equal to 60. Now we are just missing two boxes, but what we can do with this information is we will be able to set up a proportion. What was the idea of the lesson? Everybody look at your title. Using proportions to solve percent problems. Wow! Here we go. Let's set up a proportion to solve this percent problem. We are going to take this information along with this information. We don't really need students, we'll use that at the end, to set up a proportion. We can say that 40% over 60%, because that's the ratio of percentage that do not buy lunch to buy lunch. And then we're going to put our actual X over 480. Okay? So when we're using proportions to solve problems, you are going to be, okay, only when there is an equal sign. This is important because a lot of you are getting into cross multiplying when there's a multiplication sign. You can only cross multiply if you have two equal ratios, and that is exactly what we have here. Two equal ratios. Mrs. Kaloran is underlining something 15 times. What should you do? Underline it. All right, here we go. We are going to cross multiply. So when we cross multiply here, we are going to have 40 multiplied by 480, which is equal to 60 multiplied by x. So when you go through and you multiply, I'm just going to show you my multiplication over here. A lot of you like to do this way. I think this is the way Mr. Miller taught you. 4 times 0 is 0. 4 times 8 is 32. 4 times 4 is 16, plus 3 is 19, and add a 0 over there. So now we end up with 19,200 is equal to 60x. When a variable and a number are right next to each other, it means multiplication. In order to solve for x, which we are trying to isolate, we have to say, what is happening to x? And you would tell Mrs. Clark, it is being multiplied by 60. So we need to divide by 60. Okay, simple enough. First step here, move my boards off a little bit. Cancel out your zeros. Okay, then we're going to need to do some real work here. Divide 1,920 by 6. You'll see 6 goes into 1 0 times, into 19 3 times, which is 18. Subtract, that will give you 1. Bring down the 12. 6 goes into 12 twice, which is 12. And you just need to add your last 0 to finish off your division. So that tells us that x is equal to 360. Okay, what does that mean? Because what you just wrote means nothing to my problem. Remember, the question up here was, how many of the students do not buy their lunch in the cafeteria? Well, with our answer given, we know that x is equal to 360. Put a label on that, students. So that tells us that 360 students did not buy their own lunch in the cafeteria. There's more information you could find from this problem, and that information would be the only missing part, which is your total. And what would we be talking about? Total students. Now, would you have to set up another proportion to find your total students? The answer is no. You just need to add. So 0 plus 0 is 0. 6 plus 8 is 14. Carry the 1. 3 plus 4 is 7. Plus 1 is 8. There are a total of 840 students in that cafeteria. You think there's ever been that many at Maple Valley? I don't think so. Okay? Anyways, just a problem. We didn't need to find the total, but you can find the total if you do need to find the total. All right, let's move on to the next problem. Hopefully, look at my clicker. There we go. Here is a new problem. Again, a ratio box has already been set up for us, making Mrs. Killorn's life a little bit easier. So, in the town of Centerville, 261 of the 300 working people do not carpool. Okay, so 261 of the 300, so we're dealing with actual amounts, okay, of the working people do not carpool. Okay, so in this case, we are going to have a do not carpool lane. Okay, anyways, moving on from my humor. We will also have obviously a carpool lane, and then we are going to have a total part because we have a total number of people. So, in the first part, we see that there are a do not carpool part. 261 of 300, so that means 261 people did not carpool out of 300. So 300 now becomes your total. So we will write 300 people with 2 boxes in the same column. Okay, if we know 2 boxes in the same column, we can find the other one. If 300 total people, 261 did not carpool, that means we have 39 that did carpool. So we can fill that in right there. Hopefully Mrs. Killorn's math is right. You better check to make sure before you move on. And what else do we know? They want to know What percent of the people carpooled? So what are we looking for? We are looking for carpool and percent. How are we going to find it? What did we say in the last one? What's more information that we do know? The total number of people is going to represent 100%. Okay? So we are trying to find the percent of the people that carpooled, our x. So let's set up a proportion to solve. So here we are going to have x over 100 is equal to 39 over 300. In order to solve this problem, we have two equal ratios. So we are going to cross multiply. So here we will have 300 times x is equal to 100 times 39. When we multiply, we will get 300x. And over here, 39 times 100, we shouldn't need to multiply because we know with 100, we should just get 2 zeros at the end. So now in order to solve this problem, ask yourself, what is happening to the x? Because we have to get to the x by itself. So what is happening to that x? It is being multiplied by 300. So in order to solve it, we need to divide by 300. So we're going to divide both our sides by 300 to keep our equation balanced. These ones are going to turn into 1s. So we get x over here. It's actually 1x, but 1x is the same as x. And x is equal to, cancel out your zeros, 13. And you ask yourself, what were you trying to find? X is equal to 13. So the percent, I should say just percent, that carpooled is equal to 13%. If you know that 13% carpooled, you should also be able to answer the question that is next. According to one national survey, approximately 13% of the working people in the United States carpool to work. Do the carpooling statistics in Centerville reflect the national carpooling statistics? Well, let's see. In North Dakota, when we are driving to work, Mrs. Florin only lives a block away, so I don't carpool. Maybe you carpool. Ah, you do. You ride a bus. Interesting. So possibly we could take into consideration if you're working. Are you a student? Are you working? I don't know. Good things to think about. We could also calculate the percent that do not carpool if we wanted to, and we would take 100 minus 13, which is going to be 87% that did not carpool. One thing you could consider here that I want you to see, this is kind of a little bit of a shortcut. If you have a proportion where 100 times 3 is equal to 300%, that means that all of your percents. So this number times 3 is equal to 39. 87 times 3 is equal to 261, which could also show you that this number divided by 3 is 100. Divided by 3 is 13. Divided by 3 is 87. So maybe an easier way when you get simple proportions like this to solve a problem. I'm moving right along. I know we're getting close. The students had a spelling test. I'm just going to rush through this one, so pay attention and follow along. The students had a spelling test with 40 words. 6 of the words had 4 syllables. The rest had less than 4 syllables. What percent of the words had less than 4 syllables? So you can tell your subjects. We could say less than 4 syllables, and X is greater than 4 syllables. And then we also have a total. Remember, you can always fill in your total 100% here. 40 words. So there was a total of 40 words on the spelling test. 6 of the words had 4 syllables. Oh, sorry. This would be an equal sign, not a greater than. So 6 of the words had 4 syllables. So X equals 4 syllables. There are 6 of them. That tells us that there were 34 that had less than 4 syllables. So what are we going to do to solve this problem? We are going to set up a proportion, and we are looking for the percent of the words that had less than 4 syllables. So there goes our x. So now we can write our proportion. X over 100 is equal to 34 over 40. We are going to cross multiply 40 times x is equal to 34 times 100. Before we solve this problem, I want you to think about if our percent is going to be greater than 50% or less than 50%. If you can see, 34 is over or is greater than 20, which would be 50%. So you can assume our answer is going to be more than 50%. So if we get an answer that's not more than 50%, we got a problem. Okay, so here we get 40x. Here we're going to get 3,400. Easy to multiply that one. Then we need to divide by 40. 40's cancel out. Zeros cancel out. X is going to be equal to 340 divided by 4. Mrs. Lawrence having a struggling day. Let's actually go through that division. 4 goes into 3 0 times. 4 goes into 34 8 times, which is 32. Subtract. 4 minus 2 is 2. Carry down the 0. 4 goes into 25 times, which is 20. We know we have reached, the end of our division. Okay, so 85. Is it more than 50? I think we're standing good. 85% of the words had less than 4 syllables, which means 15% of the words had 4 syllables. All right. I believe I'm just going to show you these problems here in case you forgot your book. Here are your practice set problems. If you would like to complete those today, they will be due the day that we cover this lesson, so make sure they're done when you come to class. Have a great rest of the day, and thanks again for joining the Kaloran Show.